Assalamu alaikum and good day everyone. My name is Jaheera Anwar, pursuing PhD in chemistry from University Malaysia Terengganu. Today I am going to present my research work on seaweed-based green synthesis of copper nanoparticles for wastewater treatment. So these are the list of topics that I will be discussing in this session. Firstly, I'd like to start with the introduction to wastewaters. So what is wastewater? It is nothing but polluted form of water, or simply polluted water caused by water pollution. And let me describe what is water pollution. According to Environment Act of 1980, water pollution is any direct or indirect changes in the physical, thermal, chemical, biological or radioactive properties of a water body due to the deposition of waste into it, which causes adverse effect to the human health as well as other organisms in the ecosystem. Let us have a glance at the causes of water pollution. It mainly includes acid rain, industrial waste, farmyard waste, fertilizer runoff, effluents from sewage, and thermal pollutions from cooling towers, oil pollutions, etc. Now, I'd like to share some global challenges faced due to water pollution. If you look closely, in 2018, it was reported deteriorating water quality was evident for Asian, African, and South American rivers. And later in 2018, due to water pollution, a 1.8 million deaths occurred each year. And in 2019, Kim Kim River toxic pollution in Malaysia affected 6,000 people and hospitalized nearly 2,775. And in 2020, it was published that 2 billion people were living in high water stress region and 1 billion people do not have access to clean and safe drinking water and 3.4 million people die each year due to use of contaminated water. And recently, in March 2022, it was published that the global water pollution represents a major invisible water crisis. This shows that the issues on water pollution have been increasing dramatically year by year. Therefore, this is the time to think on wastewater treatment strategies and methods to provide clean water to the ever-increasing population. Coming to background study, we all know number of conventional methods like filtration, precipitation, reverse osmosis have been employed for the wastewater treatment methods. But these methods are not convincing since they could not decompose the waste completely. Therefore, currently, copper nanoparticles are gaining immense interest in the field of catalytic reduction for various organic and inorganic pollutants found in the contaminated water. Why do you think that scientists focus only on copper nanoparticles? It is because of their interesting properties like high melting point, high electrical conductivity, low electrochemical migration, and optical properties. And it also has wide applications as antimicrobial, antifungal, antibacterial, in catalysis, etc. It also possesses advantages as it is low cost and highly available. Coming to research gap, initially nanoparticles were synthesized using conventional physical and chemical methods, but they were associated with some drawbacks like maintenance and involving of high toxic chemicals. Therefore, recently biological synthesis have been used extensively due to its advantages as it is non-toxic, clean and easy eco-friendly method. So what is biological synthesis? Biological synthesis or green synthesis is use of bioactive components from plants, bacteria, fungi and algae. Of these, algae possess huge number of secondary metabolites, pigments and proteins. Hence, they act as nanobiofactories for metal nanoparticle synthesis. They also have high metal uptake capacity and they are found in abundance. Therefore, they are branded as cheap resource. Now let us see the solution that we found out for the water pollution problem. In our present study, we choose a local seaweed, Sargassum cervicone. It is generally known as brown algae and we use its extract for the preparation of copper nanoparticles, and we applied them for the catalytic reduction of harmful azo dyes. There are three major objectives involved in the study. First one, synthesize copper nanoparticle using seaweed extract. Second one, to characterize the copper nanoparticle using different analytical techniques. Finally, to determine the catalytic activity of copper nanoparticles against harmful azo dyes like Congo red, methyl orange, and methyl red. The significance of study includes the development of copper nanoparticles using S-silicone for the first time. It is eco-friendly due to the use of marine waste. It is simple single pot method which use product in high yield. It is cost effective and it contributes to the country's economy. So the methodology of our study involves four important steps. First one, collection of seaweed. Secondly, green synthesis of copper nanoparticle, followed by characterization of copper nanoparticle, and lastly, the application of copper nanoparticle as catalyst. The fresh seaweeds of Sargassum sargicon were collected from Pandak Chandring Beach, Kolaterengganu, Malaysia. Okay, now let me describe the different steps involved in green synthesis of copper nanoparticles. Initially, copper sulfate was mixed with seaweed extract and kept in rotatory shaker for 24 hours to give copper nanoparticle solution, which was centrifuged to get the pellet. The pellet was separated, dried, and made into fine powder. Now, I'd like to discuss some interesting results from my research. Here are some of the results from characterization part. So, figure 1 shows the comparative UV spectrum of seaweed extract, copper nanoparticle, and the precursor copper sulfate. The mild bands in the red line is due to SPR, which confirms the formation of copper nanoparticles. And in figure 2, the FTIR of copper nanoparticle and the seaweed extract find the similar peaks, which shows the successful encapsulation of the nanoparticle with the seaweed. In figure 3, the TEM result shows that nanoparticles are very small, ranging from 2.6 to 3 nanometer. And in figure 4, the SEM result shows the circular shape of the nanoparticles. And the green line in the EDS graph confirms the presence of copper nanoparticles. In figure 6, the XRD result shows the amorphous nature of copper nanoparticles, which may be due to successful encapsulation of the nanoparticle with the seaweed. The TGA graph shows that the copper nanoparticles are stable up to 187 degrees Celsius. The BET graph here resembles type 2 isotherm, which is generally shown by non-porous or microporous adsorbents with the BET surface area of 4.03 meters square per gram. So here is the interesting part, that is my results from catalytic activity studies. Figure 9 shows Congo red degradation and figure 10 shows degradation pattern of methyl orange and 11 shows methyl red degradation and figure 12 shows percent degradation of all three dyes. And its percent degradation in figures are given in table. Finally, I'd like to conclude with some important points. The seaweed-based copper nanoparticle were found to be in spherical shape with average size of 2.2 nanometer and BT surface area of 4.03 meters square per gram. Due to its small size, it exhibited potential catalytic activity against degradation of harmful dyes. It was able to degrade Congo red, methyl orange, and methyl red up to 97.7 and 98.8 and 91.3% in just 10 minutes. So these are the references that we have used. Lastly, I'd like to share a quotation with you. Water is a gift from Creator. Protect it and respect it. Thank you everyone for the patient listening.